Hello class, today we're going to do 3.1, introduction for introduced to vectors. First, what's a vector? Vector basically contains direction and magnitude. So here's a two-dimensional vector. So here's the right 2 points, P and Q, and you can see P goes to Q, and this is called initial point, this is called terminal point. So when you find a vector between PQ, it's just a P, like in the arrows, a P go to Q, and then parenthesis. Like this book use a parenthesis instead of a triangle bracket. So I just follow that. Okay. The importance, look at this part. So you know it's a vector. X2 minus x1 and y2 minus y1. So it's the terminal point of the initial point. So that's the vector. The geometric form for vector for 2 dimensions, so geometric form of a 2D vector. So here's the vector, and this on the x direction you get the length. Okay, the length of that is my u1. So let's say this is a vector u is equal to u1, u2. So 2 number means 2 dimensions. Now these are numbers, okay? These are numbers. This is not the same as decomposed vector, okay? It's not the same thing. This just tells you these vectors make up by these 2 components. And these 2 are numbers. So the number u1 is just the length of the u on the x direction, and u2 is on the length of y direction. Okay, so that's what u1, u2 means. And k times u means that you multiply scalar to a vector. Okay, so when you multiply scalar to a vector, you actually multiply both components with the same scalar. And for the 3 dimension, okay, for 3 dimension, so let's say your u is equal to u1, u2, u3. So that means there's 3 component here. So that's a 3 dimension. Here's an example. How do you draw 3 dimension vector? So let's say u is equal to 1, 2, 3. Okay, so let me draw it. This means that you go u equal to 1. Okay. U equal to 1, so it's a 1 here, okay? Then you go to x direction is 1. Now this is x, y, z direction, okay? And then your u2 will be, you go 2 unit, 2, and then you go 3 unit, okay, on the z direction. And then you draw a line going through the origin, okay? So that's your u. So that's your u. So u is equal to 1, 2, 3. So that's how you do the geometric form of a 3D vector. Okay. So here's some problem. First point is number 4. We are given the point P, P1, P2. This is initial point and this is terminal point. So find the vector P1, P1 to P2, you just take a terminal point subtract initial point, so P2 subtract P1, so it's a -4 subtract -6, and then -1 subtract 2. So it comes out, do the algebra, okay, it comes out equal to 2 and -3. So that's the vector here, okay. Now these all vector, these are points, and this is a vector. So this is a vector. This just simplify it. And number 8, we are given the initial point P is equal to -1, 3, and -5. And the terminal point Q is equal to ABC. And they said PQ makes a vector. Now they want to find the terminal point if they said there's a vector U is equal to PQ, has the same direction. They said find Q. So first of all, let's see what's my U equal to first. And they said U has U is equal, I'm sorry, it said that U is equal to PQ. Now they said find Q if U is equal to PQ and has the same direction for V. Okay, I forgot to write that part. Has the same direction as V, okay? And your V is equal to V is equal to 6, 7, -3. Okay, so that means that U and V have the same direction, Okay, so if the same direction, they're multiplied to one another. So that means U is equal to multiple of V. And you don't know they're one-to-one, the same length or different length, okay? So this answer answers, this problem answers many answers. So we're going to just make it easy. We're going to pick K is equal 1. So that means U and V have the same length. Because U and V have the same length, it's easier to do. So U just equal to V. And your U just equal to PQ. Okay, U is equal to PQ. We have here, okay, U is equal to PQ. And now my PQ, okay, my PQ is equal to Q subtract P. So that means A subtract -1, okay, and then B subtract 3, and then C subtract -5. And that's equal to V, which is a 6, 7, -3. So from here, we can do the algebra. So this is +1. So it's A plus 1 is equal to 6, okay. B minus 3 is equal to 7. And then C plus 5 equal to -3. And solve this, continue to solve it, and then we can get our ABC out. So it comes out A is equal to 5, okay, B is equal to 10, and then C equal to -8. So that means your Q is made up by vector. Q is a point. It's a 5, 10, -8. So that's how to do point number 8. Okay, so here's another example. This example is number 12. It said U is equal to 1, 2, -3, 5, 0. Now this is a vector here. This is a vector, okay? So this vector contains 1, 2, 3, 4, 5. So 5 dimension, 5 component means a 5 dimension, okay? 5 component means a 5 dimensions. So V is equal to 0, 4, -1, 1, 2. W equals 7, 1, -4, -2, and 3. Now these are not points, okay? These are vectors. So they said that find the expression for, I just do part B, okay? It's 3 times a 2 times a U minus a V. So how do you do this problem? We just need to, okay, it's 3 times, okay, you go 2 times the U first and then subtract V. So 2 times U, okay. So take the 2, multiply inside this whole thing here. So be 2, 4, -6, 10, and 0. Subtract V. V is 0, 4, -1, 1, and 2. So, okay, so the first part is a scalar multiply vector, okay, just to make the vector longer, become twice of that, and then subtract another vector here, okay. So now we're going to subtract it first. Oh, sorry about that. Sometimes it's hard to come up. So subtract it, okay. So 2 subtract 0 is a 2. 4 subtract 4 is a 0. -6 subtract -1 is a -5. 10 subtract 1 is a 9. Now, I want to know if you guys are following me here. So 2 subtract 0, okay, like 4 subtract 4, -1 subtract -6 subtract -1, so it becomes -6 a +1. And then 10 subtract 1, so it's a 9. 0 subtract 2, so it's a -2. So last one is a -2. Now multiply it by 6, so it becomes 6, 0, -15, 27, -6. So that's for point number 12. And the last one I want to do for this session, number 20. Number 20, they says there is a there's a find a scalar C1, C2, C3. Okay, so what happens here? Scalar C1, -1, 0, and 2, plus C2, and then 2, 2, -2, okay, plus C3, 1, negative 2, and 1. And they said it's equal to negative 6, 12, and 4. They said find the scalar, okay, find the scalar C1, C2, C3, such that these 3 vectors add together, okay, will equal to this vector, okay. So let's see it. So what we do is we just use the system equations. Now I'm going to let you know that this is called the linear combination. It means that these many vector add to this many vector add to this many vector will equal a new vector. So that's the same thing, okay? Now we just need to know how many these numbers should be, okay? So I'm going to go take the C1 multiply negative, C1 multiply inside, and then add to 2C2. So here's what you do, okay? You take this one, add to this one, add to this one, will equal that, okay? So negative C1 plus 2C2 plus C3 equal to negative 6. So that's your first equation. And then you go second one, okay? You go the second one now, with C1 for 0. So that's very nice. That's a 0, right? And then 2C2. Okay, 2C2, and then minus a 2C3 equal to 12. And then 2C1, okay, minus a 2C2, okay, plus C3 equal to 4. To solve this system equation, you can use any method you want, okay? It's really up to you how you're going to solve this, okay? So what I did was I just used a regular elimination instead of Gaussian elimination, because Gaussian elimination just have to write out the matrix, all those stuff. But this is not a difficult equation to solve, so I can just solve it easily by, you can see that from the second equation, okay, second equation only have a C2, C3, so you want to, they don't have C1, so you can get a C1, okay? So get a C1 here, then you only have a C2, C3 also. So what I did was I just take equation 1, okay, times by 2, okay, times by 2. So I have negative 2C1 plus 2C2, plus 4C2, I'm sorry, 4C2, plus 2C3 equal to negative 12. And then I add to here, okay, add them together, and then I will create a new equation. My new equation will not have a 2C1 anymore, that's gone. And then I add 2, so 4C2 minus a 2C2 be 2C2, okay. 2C3 plus C3 will be 3C3. And then negative 12 plus 4 is equal to negative 8. So I get a new equation. And with my equation from here, okay, that's 2C2 minus a 2C3 equal 12. And then I just solve this one, okay. I can, now regular elimination, you can subtract it, okay. I can just subtract the two equations. So 2C2 subtract 2C2 is 0. 3 subtract negative 2 is equal to 5C3. Negative 8 subtract 12 is equal to negative 20. Okay, then I can get C3 is equal to negative 4. And then once I get C3 equal to negative 4, I can just go find my other one, okay. So my other one will be, and then I'm going to put C3, okay. I put it back into either one of the equation, okay. It's up to you where you put it. So I just put it right here, okay. I solve for C2, and then my C2 comes out equal to 2. And then I put C2, C3 inside. Up to you, okay. I just put it right here, and then I get C1, okay. Or you can put it in the third equation also. And then comes out C1 is equal to 6. So that means I need 6, now I need 6 this vector, 2 of this vector, and then take away 4 of this vector, I will get this new vector. Okay, that's what that means, okay? So that's for today's lesson, 3.1.